Hello subscribers, welcome to Stematics tutorial. In this video, we are going to see multiplication theorem of expectation for n events. But before this, please go through addition theorem of expectation for n events. That link will be given in description.
Multiplication theorem of expectation for n events. So here statement, let x1, x2, so on xn are n independent continuous random variables. Then prove that expectation of x1 into x2 into so on xn equal to expectation of x1 into expectation of x2 so on expectation of xn. So this theorem is similar to that of addition theorem of expectation for n events. So same like addition theorem only we are going to prove this theorem. So those who didn't see that video, please see that video and then come here so that you'll understand clearly. So here in proof we are going to prove this theorem by using mathematical induction only. So by using mathematical induction we are going to prove this theorem. So here we will have three cases, same like addition theorem. Case 1, we prove this theorem for two events. So let us assume this equation as statement equation as equation star. So we'll write that to prove that equation star is true for two events. Equation star is true for n equal to two events. So what we'll do here, directly we are doing here because same from addition theorem, same like addition theorem only we are going to solve this. So before who are seeing this theorem for first time, so please go through addition theorem once and then come back here, you will understand clearly. So what they have given in the statement, let x1, x2, so on xn are continuous random variables. Now here we are going to take let x1, x2 are two independent random variables, continuous, sorry, not direct random variables, that too we are mentioning the type continuous random variables. So since these two are random variables, sorry, independent random variables, so are two, since x1, x2 are two independent continuous random variables or two independent random variables, so we can write, we have f of x1 equal to f of x1, x2 equal to f of x1 into f of x2. This is very important here. So since these two are random independent random variables, f of x1, x2 becomes f of x1 into f of x2. Take this as equation 1. Now consider, so our main proof starts. Expectation of x1, x2 equal to integral x1 equal to minus infinity to plus infinity, x2 equal to minus infinity to plus infinity, x1 into x2, x1, x2, no, it is x1 into x2. So x1 into x2, f of x1, f of x2, dx1, dx2. So now we have to split this integral x1 equal to minus infinity to plus infinity, integral x2 equal to minus infinity to plus infinity, x1, x2. So f of x1, x2 becomes what? F of x1 into f of x2, substitute that, f of x1 into f of x2, dx1, dx2. Since from equation 1. So where you have written that, from equation 1 you have written that. Now you can split that equation. Equal to integral x1 equal to minus infinity to plus infinity. So x1 terms we have to write x1 into x2. So here we are having x1. So x1 I'll take here, and still any more x1 terms. So here one more, f of x1 and dx1. That's it. Anything else? Nothing. So into integral one more, x2 also is there. x2 equal to minus infinity to plus infinity, x2 into f of x2 dx2. So only these are the x2 terms we are having. This is what this represents, expectation of x1 into this equation represents expectation of x2. Therefore expectation of x1 x2 equal to expectation of x1 into expectation of x2. This is equation 2. Therefore equation star is true for n equal to 2 events. So I'm telling you before itself, once again I'm reminding you, if you see addition theorem only, if you understand that only, you will understand this clearly. So please refer the addition theorem given in the description, then you come back here. So why I have written here directly, you will understand in that video. So next, so case 2, case 1 is done. Case 2, assume that equation star is true for n equal to k events. Equation star is true for n equal to k events. So here we are assuming that. So directly we can write down the statement, expectation of x1, x2, x1 into x2 into so on xk equal to expectation of x1 into expectation of x2 so on expectation of xk. So this is our equation 3. Next, case 3. So what we are going to do here? Case 3. Now to prove that, what we have to do in case 3? Case 3 we have to prove that equation star is true for n equal to k plus 1 events. K plus 1 events. So expectation of x1, x2 so on xk into xk plus 1 events you have to take in the left hand side equal to what we will get. So here by using equation 2 we have to solve this. So let us assume this as x1, this as x2, same like addition theorem. So expectation of this becomes expectation of x1 into x2 equal to expectation of x1 into expectation of x2. Now what is our x1 here? x1 to xk are our events in x1. So expectation of x1 into x2 into so on xk into expectation of x2. In place of x2 we are having expectation xk plus 1. So expectation of xk plus 1. So from where we have written, from equation 2 we have written this. We have split this. Next, what is expectation of x1 into x2 into xk? Equation 3. See here, expectation of x1, x2, so on xk equal to, you can write this directly, expectation of x1 into expectation of x2, so on expectation of xk. So by this, we have written this from equation 3 into expectation of xk plus 1. So by equation 3 we have written this step. Next, therefore, expectation of x1, x2, so on xk plus 1 equal to expectation of x1 into x2 into expectation of xk plus 1. So hence the theorem is true for n equal to k plus 1 events. So if you want n directly, you can replace it with n also, expectation of x1, x2, so on xn, because we have taken here n equal to k plus 1. So I have substituted this equal to expectation of x1 into expectation of x2, so on expectation of xk into expectation of xn. So this is our theorem, multiplication theorem for n events in terms of expectation.